You happy with that? Ryan's happy. Everyone's happy. Any others that I picked that yeah, I remember picking that one thinking, oh, this will be fun. I'll be going over that one. But it was mainly because I was happy about the fundamental theorem of calculus because that's my favorite theorem in all the world. Anything else while we're doing this? You can do derivatives. Like if it's simple, like you could do these derivatives. Those are easy because that's all the quiz is. The quiz is just the basics, the easy derivatives. Polynomials. I've got a cosine and an e to the y. You can do e to the y. You can handle it. Let's give it a go. See how this works. I'll bet you'll be fine. 1, 2, 3. There you go. Enjoy. We'll trade. 2, 3, 4. I don't know what that's for. Still let me know. There's only 3. There's one more. There's a bunch. Here's a bunch. I'm sure that there's an extra one there somewhere. Oh, you did the wrong spelling? Nice. Well, like you practiced. That's all I really. That's why So I split. I'll split when I look at the page. Oh, that looks like you're doing something. You have an extra one? Okay. Anyone want an extra? I guess we can average together the two. If you're not sure, let me know if there's like. Yeah, we could average together your 2 attempts. Okay, let's find the quiz. Statistics, calculus. Just a quick note, this is supposed to be f sub y. I guess that I didn't subscript the second y. Here, I'll put it, I'll fix it. Here, just a sec. So it's that letter C, should be f sub y. You might have noticed that, or maybe you ignored it. So those are 2 subscripts, like that. All right, you're probably all done. I just wanted to make mine look pretty. There it is. Okay. There, I'm done. Sorry. You'll see. Okay. Yeah, if you are done, go ahead and pass it over. If you're finishing up that final product, I know you want to make it look pretty because you didn't make the last one look pretty. Throw some curves on there, but don't make circles. Yeah, it's not circle. Trust me. Very nice. Beautiful. Not circle. Good. This up here. Variable. You've got some non-circles. Yes, very nice. Looking good. Shaggy snake is. Not circles. Those aren't circles either. Not circles. Finishing up. Very nice. All right, if you're not done, finish up. Because now is the time to paint. So try to wrap things up. You've got some non-circles. Oh, I love those. Beautiful. We have some. Ooh, very nice. I like it. Finishing up some beautiful curves I see. Oh, nice. Ooh, yeah. See that something? All right, good job. I like it. Yes. Good work. Good job. Good. Good job. Yeah, I like it. I like it. All right, I think I've got them all. You've got you're holding out, aren't you? Oh, we got one more holding out. Okay. Yeah. Yeah. You got your derivative? You got finishing up derivative. All right, I'll let him finish his derivative, and then I'll show you what I got. Oh, is this for me? I know you're tempted to mess it up, but yeah, always a temptation to do too much, especially with the chain rule. Let's staple these. Good. All right, let's do this. So we've got this. I think that maybe I was, I get a little excited about trying to make things interesting, and I have to pull back. I realize I've had this talk with students before where they tell me, listen, if it's interesting for you, it means it's impossible for us. Okay, I'll pull back as much as I can. But anyway, I found this to be more interesting than a boring polynomial. But I know it's probably a little bit harder than I had intended. But you have These are all straightforward functions. Remember, y is a constant with respect to x. And so when I do the derivative of this, it just goes along for the ride. It's just, x squared times a constant, so 2x times the constant. This e to the y is constant, so it goes away. This cosine of x plus y, that's like the cosine of x plus 7. The derivative of cosine of x plus 7 is negative sine of x plus 7. Done. There's no chain rule involved. Well, there is, but it's the chain rule. You just multiply by 1. So anyway, there's that one. The rest of them are very similar, but if you got the first one right, you probably got the rest right. If you didn't get the first right, I'll try to read with you in the sense that, you make the same mistake multiple times. I only take off once for it, that sort of thing. So here's my derivative with respect to y. We can zoom out so you can compare. It's almost the same. The only difference is that e to the y stuck around. But oddly enough, derivative of cosine x plus y is the same whether you're doing it one way or the other. I thought that was kind of interesting. I know. Once it's interesting for me, it's a nightmare for you, so I apologize. Here's the second derivative, the one that I messed up the subscripts for. So this is the derivative of this with respect to y. So notice that I just do the derivative of cosine 2y, which is 2 times sine of 2y, negative. And then the e to the y just comes down, and the derivative of negative sine of y is negative cosine of y. I know there's an x in there, but you're treating the x as if it was a constant. Up here, we're moving our to the right. So you have a, and you're doing the derivative of that with respect to x. And then we did the mixed second partial, which is this thing down here. And yeah, there's a temptation to just throw something else on here, but this is it. This is it. Here, where did that come from? Well, I took this and I did the derivative of that with respect to y, and I got this down here. Okay, there it is. So let's deal with our sketching of our contours. So here is the sort of thing you should have been doing. You get x squared minus y is equal to some number. Yes, sir. Oh, sure. Yeah. Sorry. Oh, and I've got 2 f's there, don't I? So that's problematic. Okay, so you want me to go the other way. Yeah. So you take this. I did it this way, but it is the same thing. So you can mix it up however you want, but you'll start with this and do the derivative of this with respect to x. So that's going to be 4x. That's going to be 0. And this is going to be cosine of x plus y. So that's what you get. So it's the same way either way. But you're right. Technically, I should be going the other way. And that's only going to make a difference if you have some wacky function that we aren't going to deal with those wacky functions in here. So for all intents and purposes, f sub x, y is the same as f sub yx. They're the same. Okay, so let's get back to this. Here's what we're doing. There's 2 of the contours. So you have x squared minus y equals 0. So you're taking the function. Where's my function? Take that, set it equal to some number, like 0 or 1. And so you get x squared equals y, which is same as y equals x squared. Nice parabola. And then this, I don't know why I have a square there. I guess I got excited. So x squared minus y equals 1. Rearrange that. Oh, I need this. And you get y equals x squared minus 1. So it's the same parabola, just moved down. So I got really excited here and made a whole bunch of them. So anyway, that's what I was doing up here. So you got a bunch of parabolae. Technically, it looks like this. I saw some of yours look more like a rainbow. I mean, whatever. I'm happy that you know that there are a bunch of parabolae that you put up there. So yeah, as you move this way, you're going up. So this is 0, 1, 2, 3, 4, 5. And then this is -1, -2, -3, -4. If you're curious, if you have them labeled. But there it is. Beautiful. So it's getting better because I saw a bunch of things. They might not have looked like mine. Here's what I saw as I was looking around. It's like this sort of thing, which technically is not the same thing as this, but it's a lot better than if you were doing this. So thank you for not doing this. Okay, let's move on though. So today, super easy. I know I told you last time was super easy, and apparently I lied. So today we're going to do tangent planes. So I've got this box because that's the closest thing to a flat object I could find. Actually, I have a folder. The folder probably better. And I have this chair, and the chair cushion is like a surface. And so you can imagine that if you're standing on this surface right here, if you're really little, like an ant, it feels like you're on a plane. So zooming in really far to there, we get this thing that looks like a plane. Here, I'll just leave it closed. So there is a tangent plane right there. This is a tangent plane. These are all tangent planes. So if you take a flat object and put it on a surface, you get a tangent plane. That's all we're doing today is tangent planes. I want to be able to come up with a tangent plane. So here's how we're going to do it. Here, we'll go back to PowerPoint. Not that. That's my binomial random variables. Let's discard that. That was from statistics. Let's see, where is what we're doing here? Tangent planes. This looks right. Okay, so for example, we want to find the tangent plane to this gumdrop, which is what it is, or if you like Dots candy, that's what this thing is, 9 minus x squared minus y squared. Here, I'll show this to you. There it is. So you can see it does look like a gumdrop or a Dots candy. And I want to know the tangent plane at this point, 1, 2, 4, x, y, z, 1, 2, 4. So there is the point. I know it's hard to see. It's that little tiny dot right there. You see it there? So that's the point 1. So you're going 1 in the x direction, 2 in the y direction, and then 4 in the z direction. How do I know it's 4? Plug 1 and 2 in for x and y, and you get 4 for f of x, y. So that's that point there. I want to know the equation of the tangent plane. Now, you know the ingredients to a tangent plane, or rather the ingredients to a plane. The ingredients, if you look at the recipe card, you will find that you need a point and you need a vector. The vector is the normal to the plane. So if I have these two things, I should be able to come up with a tangent plane. Unfortunately, all the vectors that I know about are vectors that are not normal to this plane. For example, I know that I can come up with f sub x, and f sub x at that point, let's see, do I do it? No, there's just a plane there. Yeah, this is what the plane looks like, by the way. But let's pull that back for a sec. So you can imagine f sub x is going to look something like that. You're standing on this gumdrop, and you're looking in the x direction, which is this. So you're kind of looking downhill. It's very steep downhill. Same thing goes for f sub y. F sub y is going to point steep downhill, but it's going to go something like that direction. So you have to sort of imagine standing there, look in the y direction, and then look in the x direction. And you have these two vectors, f sub y. However, I bet you can guess what's going to happen now. I have two vectors that are in my plane, in the tangent plane. In fact, here I'll show you what the tangent plane looks like, so you can kind of see that. Those two vectors are in my tangent plane. Do the cross product, right? Cross product of those two vectors, and you get the actual vector that you're interested in. So the normal will be the cross product of those two vectors. Now, one thing that we need to do, and that is to translate f sub x and f sub y into vectors, because f sub x and f sub y are slopes. They are not vectors. So here's how I'm going to do that. Bear with me for just a sec. And so this is the mathematician. This is the mathematics thing. In just a minute, we're going to get to the point where you're like, well, that's all I care about is the formula. We'll get to the formula in a sec. But the mathematician says, I want to know where this formula came from. So here is the vector. The red vector is going to be this vector. I'll write it in vector form. I'm going to be going 1 unit in the x direction, 0 units in the y direction, and f sub x units in the z direction. Let me just explain briefly what this means. That if I'm going in this, of course, you're not going in the y direction at all. That makes sense. But that is a slope. A slope is rise over run. So rise over run, if the slope was, say, -2, it means you go down 2 for every 1 over that you go. So go over 1, go up or down, however far the slope is, and you get a vector, and that's that vector there. At that point, I can do the same thing for the blue vector. The blue vector is 0 in the x direction, f sub y in the y, I'm sorry, I blew that. Let me try again. Get rid of that. Okay, 1 in the y direction. Slope is rise over run. So rise over run, I'm going over, so the run part is the y direction, and the rise, or fall, in this case, is the z direction. So rise over run, f sub y over 1 is the slope. And so that's that vector. Now I just do the cross product of those two vectors, and that's going to give me my normal. And it turns out that the cross product of those two vectors, the normal, ends up being, let's see, did I do this? Yeah, I did it. It's f sub x negative, sorry, negative, let me restart this just a sec. Restart, get rid of all that. Okay, let's try again, do it right. The normal to this plane is going to be negative f sub x, negative f sub y, and 1. So you can do the cross product if you like. It's pretty easy because of all those zeros. And you put that together with your knowledge of the way that you do tangent planes, while I just fix something that I just noticed. And you will have your, here we go. Does this do it? Come on, fix. Oh, come on. It's not going to fix it. I'll just have to write it down because, see, look at that. That's so bad. So I'll just, I can fix it right here. So here's the equation of a tangent plane. So you're going to take the point, you're going to take the normal, put it together, and fortunately for us, what that results in is a very simple to remember formula. So the simple to remember formula is this, and we're going to do it with this particular function in just a sec, but it's z minus z0 is equal to f sub x of x minus x0, y0 times this plus this, hold on a sec, times that. There we go. That looks better. I suppose I could even go so far as to put the z0 on the right side, and then I just have z equals all of this stuff. Let's actually do this for the gumdrop so that we can see what that formula is. So if you'll forgive me for switching back and forth here, here is my information that I need. I need to know what f sub x is and what f sub y is. I know that you know how to do this. This will give me a chance to fix my attendance as well. So give me a minute here. Manage and fix. There you go. You have been fixed. And now I can just do random people. So Cooper-Stiegel, what is the derivative of this function with respect to x? Nice work. Cooper-Claggett, what about the derivative of that function with respect to y? Nice work. Okay, so we're almost done now. So we're going to combine this with the normal. So let's get the normal. And the way we get the normal, actually, we don't even need the normal. Let's just go use this. So let's see, back and forth. I know it's annoying. So yeah, we'll do the one up there in just a minute. But let's do this. Z minus Z0. So let's go back here. What is Z0? There is Z0. This is the point, X0, Y0, Z0. So Z0 is 4. So Z, that's my initial, that's the Z value of that point that's on the plane. So Z minus 4 is equal to, I need to know the slope in the X direction at that point. Breyer, what is the slope in the X direction at that point over there? -2. So you're just plugging x equals 1, y equals 2 into this, and you get -2. Very nice. So that's going to be -2 times x minus 1. I choose 1 because the x value of this point is 1. Now I need to know the f sub y at that point. Caden, do you know what f sub y is at that point? It is negative 4. So there you're just plugging in y equals 2 into that, and you get negative 4. So that's going to be minus 4 times y minus 2. And that there is the equation. I suppose you could move the 4 over to the right to make it look cleaner. We could also multiply through by everything, make it look a little bit better. But that is the equation of the tangent plane. Let's try this again with another example. The one right above there. So I want to find the tangent plane of that at the point 1, 1, 1. So go ahead, see if you can come up with the equation of the tangent plane for that function at that point. And I'm going to make this on Notability because it'll be a heck of a lot easier for me. Okay, copy and delete. Okay, bear with me for a sec while I copy this and paste it. Why is that not moving? Nobody knows. It's frozen. Yes, I've broken it. Okay, let's just delete. Let's go back here. Try again. Sorry about that. Now it's moving. There. This way. All right, I know everyone wants to volunteer for this, but we'll just have to pick Madison. Madison, what is the derivative of this function up here with respect to x? Ooh, okay. I'll take the negative 6, but I'm not going to, I got to have something else up here. So let me rewrite it for you real quick and see if I like the negative 6. So you could have written this way, x squared plus y squared. Don't forget that even though we're treating the y as if it's a constant, oh, sorry, negative first power. Even though we're treating that y as a constant, it still is something. It doesn't disappear as much as we'd like it to go away. And so I like the negative. So I'm guessing that you saw this and you're like, okay, multiply by negative 1. And then you've got the x squared here. So that's where the 2 made that into a 6. So let's see. So I'll work through this. So negative 3, I'm going to actually write it out completely to make sure that we get it right, plus y squared. So it's almost right. And then it's going to be to the negative 2 power. So using the chain rule, and then multiply by the derivative of what's in the parentheses. And what's in the parentheses, the derivative is 2x. That's where the y goes away. So the y does go away eventually, but you have to be careful about where it goes. So this will actually be 6x over 1 plus x squared plus y squared to the negative 2 power. So yeah, just be careful with make sure you keep all of this stuff around, and it might be safest, especially with all of these extra variables, to sort of write it out like this. There's the function using the chain rule. That's all good now. So is any questions about the chain rule here? Because I know it's uncomfortable. Oh, yes, sorry. You're right. I got excited about my negative, but we don't want to be too negative because a double negative. 2 wrongs don't always make a right, but 3 lefts or 3 rights do make a left. Isn't that the saying? Something like that. Okay. So does that look all right now? Okay, so next, let's do f sub y. Now that we've got f sub x cleared out, I'll bet you that f sub y is going to be easy for you. But Ryan, what did you get for f sub y?
Negative 6y over, this is 1 plus x squared plus y squared squared.
Yeah, and this is exactly the same sort of thought process. You're doing the derivative of this with respect to y now, multiplied by -1, this to the -2, and then the derivative of what's in here is the 2y. So eventually the x does go away. Yeah, you just have to be careful of all the little tidbits and parts there. Okay, next, I need to know what is f sub x evaluated at 1, 1, and what is f sub y evaluated at 1, 1. And you might wonder, where do we get that? Well, it comes from this, the fact that x, y, z, there's where the 1 and 1 come from. So plug that in. I'll give you a minute to do that. And then we'll see what we have. Oh, I have my volunteer list here. All right, Rachel P., what do you get for your f sub x evaluated at 1, 1? Okay, very nice. So I'm just going to write it like this, just in case anyone's not sure where that 2/3 came from. So obviously the 6 times 1, and then on the bottom, 1 plus 1 plus 1 is 3, squared is 9, and it does reduce to -2/3. Very nice. All right, Andrew, what about f sub y evaluated at 1, 1? What do you get? Oh, it's the same thing? Okay, I guess it is. Yeah, it does make sense since this is sort of symmetric here, and I should have picked a better point, but that does it. Okay, very nice. Now the final step is to put this all together into the final answer, which is the tangent plane. So I'll start it off here, z. But Emily, how do you put the rest of this? What am I going to put here for the rest of this tangent plane? So it's up here. I need to just shove everything in.
Okay, so it's z minus 1 equals -2/3 in parentheses x minus 1 minus 2/3 in parentheses y minus 1.
Beautiful. That's amazing. So good. This is bringing back some bad memories for me, though. Only a little bit, though. You remember there was a problem, I forget which one it was, where you had to write down a line, and in the line you had cosine of t. You never have cosine. It's always linear. So here, same thing. Planes will never have anything other. It's going to be something simple like this. Here's the memory that I'm having that's coming back to me is some students want to do something like this. Give me a sec here. I'll doctor this up. Instead of putting their thing like this, they say, oh, okay, it's going to be z minus 1. They get that part. And then they say, okay, f sub x, there's f sub x, times x minus 1. And then let's do f sub y. And here's f sub y once I doctor this up a little bit. This times y minus 1. Well, right off the bat, you can see this is not a plane. I don't know what this is, but it certainly is not a plane because you have, well, x squared down here, y squared, not a plane. So this, not a plane. A plane. A plane is going to look something like this. That's a plane. So just be careful when you do these things, especially on the test next week. Did I mention we have a test next Friday? I think I did. So make sure that you do it right. Planes should look like this. No sines or cosines. Okay, onward. 2 more things. We're almost there. We're coming home. Okay, so the next thing. We've done tangent planes. They're easy. The next thing we need to deal with is something like this. I know, it's the same thing. You're sick of the wind chill factor. So let's find the tangent plane at this point. Approximate, I should say. Approximate the tangent plane. So let me put this on Notability because I have no room up here on PowerPoint. Give me a sec. Copy and paste. Come on. And back there. Okay, so here is this wonderful chart that we're getting sick of. And I want the tangent plane at this point, 0, 30. So 0 is temperature. So T equals 0. And 30 is the velocity, the wind velocity. Okay, so here is what we're looking at. This point, where is 0, 30? I think it's this right here. Okay, so if it was 0 degrees out and the wind was blowing 30 miles per hour, it would feel like negative 26. And if the principal of East Elementary School decided to keep the kids in that day, I think I would agree with him or her. Because that's quite cold. So, you know, you put your hand out there and you get frostbite instantly. So, oh yeah, frostbite times. Okay, apparently you still have, what is that, 10 minutes at least? You have more than, you could be out there for at least 10 minutes.
Oh, they got you 30.
Well, 30, oh, is this 30 or is this 30? Yeah, I guess this is 30. Yeah. The kids could go out for a full recess.
The light blue is just
Okay, you're just fine in the light blue. You're right. So yeah, my kids would have really been mad if it was like this. But anyway, getting back to the situation here, I need to approximate. So you know the deal is we will approximate dt over, or d, what are we calling this? Wind chill. D wind chill, dc chill, whatever it is. dc over d, here it's this thing is the wind chill. dc over dt and dc over dv. Maybe I should have used w for wind chill. Whatever. And so here, once again, we're going to approximate. So you're going to have stuff like this on your homework. Just approximate and do it however you want to. I'm going to do this. So this, I will go put an arrow like that to approximate the v over dt, or dc over dv, sorry. And this is going to be the other way. Here, let's see if I can do this. Now I've obliterated all the numbers, but I'll do my best to read this off. So the temperature is going from right to left. So this will be approximately over 10. So it's increasing 10, and you increase, let's see, 1933 is a 14? 14? Is that right? So we've going from this point to this point, you have increased the wind chill from negative 33 to negative 19. That's an increase of 14. And then the actual temperature went from negative 5 to positive 5. So it's a 10-degree difference. Okay, with wind velocity, you just need to go check 25 to 35. So that is also a 10 mile per hour, 10 mile per hour difference. And it looks to me like the wind chill changes from negative 24 to negative 27, which is a change of 3. A negative difference, though. So negative 3. So we can put this all together and come up with our wind chill. I'm going to put the negative 26 on the other side. So I'll put this negative 26 over here. Here, I'll show you what I just did, just so you don't get too scared. Copy this. Copy. Oh. Okay. So this, instead of writing it like that, I just wrote z is equal to z0 plus f sub x, dot, 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 dot. So notice you could take that, move it to the other side, it becomes positive. It just makes it a little easier, especially when you have a negative, which you can't tell now because I've completely covered up that, but that is negative 26. So we're going to start with negative 26 plus the temperature difference is, or the slope in the temperature direction is that, and my temperature is 0, so T minus 0, and then negative 3/10 times the velocity minus 30. And so this would be the way that I could approximate the wind chill when I'm close to 0 and 30. So if, for example, the wind was blowing 32 miles per hour and the temperature was -3. If the temperature was -3 and the, so I would do this, let's see, -3 comma 32 is going to be approximately -26 plus 14/10 times t minus -3 minus 0, because the t here is -3, isn't it? Okay, we'll try again. -3 minus 0 plus -3/10 times 32 minus 30. That's a lot of tenths, isn't it? So 26 minus 52 or 42? Wait, 42. 42/10 minus, that's going to be 2/6. And so that's going to be 4.2, 4.8. So that would be approximately -30.8 degrees would be the approximate wind chill at that point. All right, look at this. We have 4 minutes left, 3 minutes left now. We got one more thing to do, and that is differentials. Everyone's favorite is differentials. So this is easy though. So if you have z is equal to f of xy, then it turns out that dz, the differential, dz is going to be f sub x times dx plus f sub y times dy. And I say this is all your favorites because I know that some of you have taken physics and had to deal with differentials or at least error approximations. That's where this is handy, is if you have, for example, I'll just do this with a very simple thing, and then you'll have it on your homework with slightly more complicated. But let's say that we have the volume of a box is x, y, z. So let's see, the volume, here, I'll draw my box. Here's my box. There it is. So we have x, y, and, oh, no, that's z, isn't it? And y. And let's just suppose that my box is 20 centimeters by 10 centimeters by 15 centimeters. And then suppose that I say that there's a change, that we have a change in x of, I don't know, 0.5 centimeter, a change in y of 0.2 centimeter, and a change in z of 1/10. These could also be error estimates, like you've measured these to within 0.5 centimeter, 0.2 centimeters, and so on. And I want to know what is the change in the V, the volume. So the way we're going to do this is we compute the differential, capital or D capital V, is equal to the derivative, the derivative of this with respect to x times dx plus the derivative of that with respect to y times dy plus the derivative of that with respect to z times dz. And then we just plug in all of those numbers and you get the differential with respect to v. And you might wonder, how is this at all related to planes? Well, this is the tangent plane formula. The change in y, or the change in z, so here, z minus z0 is f sub x times x minus x0 plus f sub y times y minus y0. So differentials is just a tangent plane, and you can just plug in those to get your approximate change in v. Do your best. We'll see you on Friday. You get the day off tomorrow, by the way. Isn't that nice? I'm going to stop the recording in case you want to talk.